Ladies and gentlemen, we are kicking off the first day of the AI Plus Expo with a discussion of Lockheed Martin and DARPA's approach to building scalable, secure, and mission-driven AI capabilities for national security missions. Please welcome Greg Forrest, Vice President of AI Foundations and Commercialization at Lockheed Martin, and Dr. Kathleen Fisher, Office Director for DARPA's Information Innovation Office. The conversation will be moderated by Ben Brody, technology reporter at PunchBowl
That
News.
was the seat that I wanted.
They gave us the...
Welcome to our fireside chat. This is AI for National Security Missions. I am Ben Brody. I'm a tech reporter for PunchBowl News. We focus on the power, people, and politics inside and outside the US Capitol. You should check us out. But I am so excited to welcome Kathleen and Greg to discuss this topic. We've all been chatting, and I think you guys are in for a real treat. No one here needs me to tell you how intertwined artificial intelligence and national security are right now, or how much more intimately they'll be tied together in the years to come. Technology, competition, and security have all been paired up since the advent of the stirrup, and the AI age will be no different. Building AI capabilities that address our strategic needs, that make our defenses more powerful, and that can be delivered where and when we need them will be one of the greatest challenges of the 2020s and beyond. Fortunately, we have these two working on it. To my far left, Dr. Kathleen Fisher has been Director of Information Innovation Office at the Defense Advanced Research Projects Agency since 2022, your second stint at DARPA. Also previously chaired the Computer Science Department at Tufts University, spent time at AT&T, and got her doctorate in computer science from Stanford University. Greg Forrest, VP of AI Foundations and Commercialization at Lockheed Martin, where he leads development of robust, scalable AI and machine learning capabilities. He oversees a portfolio of initiatives, including Lockheed Martin's AI Factory, which I believe we'll be hearing a little bit about.
Sure.
Well, you guys aren't here to hear from me, so I'm just going to kick it off to you guys. Do a level set for us. Where are we right now when it comes to the intersection of AI, national security, and deployment?
Sure. You want me to start?
Please.
For us, it's we really want to take the best of what the commercial world is doing in big tech and be the best at rapidly applying that into the DoD domain, right? And so what that means for us is we need to be thick integrators of artificial intelligence. So we need to own the platforms in which we build AI. And so when we think about that, we think about things like machine learning operations, we think about generative AI platforms, and it's not just about what we build for our customers, it's about how we build for our customers. And to show that transparency to the customers that we deliver to is really, really important. So you take that and you combine it with a very large effort that we have across Lockheed Martin to completely transform our business digitally, and that starts with artificial intelligence. So the more efficient that we can get as a business, the better capabilities that we can provide to our customers, right? And ultimately, we can support national security. And so that's really our approach. Our goal is to be the leader in AI in aerospace and defense, and we've been investing for many years to put ourselves in that position.
Yeah, I would say it's like obviously we're seeing explosion of new capability coming out of AI companies, which is, fantastic, right? It seems like every week there's a new announcement with game-changing capabilities that are astonishing, which is fantastic. But the capabilities are kind of idiot savant, right? The savant is amazing, but there's still also on a regular basis, there's oh, but it can't do this or it does that weirdly. So, and the companies are racing to deliver those new capabilities to create markets for revenue, because those new capabilities come with a really steep price tag, and that market is largely a commercial market, which is 100% makes sense. A lot of those capabilities are well aligned for national security applications, and so the national security infrastructure can just take advantage of those capabilities and can deliver into a pipeline for national security. But the alignment isn't perfect. There are national security applications that are not exactly on that roadmap. And so what the national security ecosystem needs to do is figure out how to adapt and how to invent new technology. DARPA's mission is looking over the horizon to figure out where surprise is coming from. And so what our mission is to figure out where that alignment isn't perfect and where we need to invent a different future, create new technology, and where we can adapt the existing technology to serve that national security imperative.
Yeah, I'm just going to bounce it right back to you. I mean, from both of your perspectives, how do you ensure that alignment between what's coming out of the private sector and the government needs, the national security missions?
For sure.
Yeah.
So there's so much excitement.
I know. Who wants to go first?
Go for it.
You know, I think there's a couple key components to that. The first is to be able to rapidly develop and field and get this into the hands of our warfighters, the folks that are on the ground. You have to be able to build, learn, and reiterate. And to do that, you need machine learning operations, you need automated pipelines, you need to go all the way from how you curate and label data and then train your model and then monitor that model in the field. I think that's really critical to ensure that the missions are actually aligned in how we do that. And then, like I said, bringing the best in from the commercial technology world and rapidly applying that into the DoD space is really where we are focused. So.
There's other places where we can directly partner with foundation model companies to explore the state-of-the-art technology. So DARPA is doing that with the AI cyber competition, or what we call AICC, which is taking the premise that we can pair cyber reasoning systems with state-of-the-art frontier models to automatically find vulnerabilities in open source software, but more importantly, to fix those vulnerabilities at speed and scale. So this is a competition that we're running right now in partnership with Google, Anthropic, OpenAI, and Microsoft, where those companies are providing API access to their state-of-the-art models, and as those models evolve, the access to those models evolves as well. The competition, we had the semifinals at Black Hat in August of last year. The finals are going to be at Black Hat this year. They had 42 teams compete. The top 7 advanced to the finals. Each of those 7 teams won $2 million in prizes. We were super excited about the results of that competition. They competed on 5 mainstream open source platforms, including the Linux kernel, Nginx, SQLite 3, so really mainstream platforms that are used everywhere in critical infrastructure, but also like just everybody uses those open source platforms. The teams found 22 of the synthetic vulnerabilities that the organization that's running the competition planted. They found 1 0-day. But the thing that is truly game-changing is that they fixed 15 of those vulnerabilities, really offering the promise of a much more secure future. So we're really excited to see what the teams do at the finals in DEF CON of this year. If you're going to be at DEF CON, we welcome you to come to the AICC village to really get to see how the teams do. Another thing, so like that's an example of taking the technology and figuring out how to leverage it for national security endpoints in terms of cybersecurity. Another thing that we're doing is we're looking at the foundational science and understanding, well, where is the foundational science lacking for national security, and how can we jumpstart efforts in basic science towards national security? And here we are looking to set up a consortium with the National Science Foundation, with DARPA, and with foundation model companies to partner with academia to get them focused on problems related to national security that are not on that basic roadmap for commercial capabilities that would pay the bill for foundational model companies, but would be game-changing for national security. And that if we had breakthroughs, would be great for commercial opportunities as well, that would nudge the commercial companies to adopting those. Things like multi-level security, which is really, really important for national security, would be great to have for commercial, but it's not like on the basic roadmap. So we are working to stand up that consortium to create faster adoption for industry and academia for that kind of national security application. We're working to stand up a committee of, a board of national security experts to help guide that research in the future. The details aren't all yet worked out, so stay tuned. You can go to the DARPA.mil workshop and workshop website and sign up for a mailing list out of my office to get details later on this summer. So that's another example of what we're doing to stay on top of the very fast horse of AI development.
Yeah, Greg, take that from the private sector. How do you identify the places where the government has mission needs that the private sector isn't addressing? And particularly, how do you accelerate them? Because part of the AI national security question is how fast it moves.
Yeah.
So how do you as an organization address all that?
Yeah, so we look at the thousands of programs we have across the business, and it's interesting, as a centralized organization at Lockheed, we're providing foundational infrastructure and in an ecosystem for our teams to go build those AI models in support of those customers. So we use our vast ecosystem that we already have established across the Department of Defense to go dive into those needs, right? And so, a recent example for us over the last, 6 months or so, there was a big need in the Red Sea with the Houthi attacks, right? And so what we attempted to do with our Navy customer was, how do we reduce the false alarm rates for operators on the Aegis system? And we collected a whole bunch of data as we were doing that. We run our automated machine learning pipelines, and this is where the private-public partnership piece comes in, right? We have a machine learning operations pipeline that enables us to do that. But when you get into test and evaluation and red teaming of these models before we can actually go deploy, right? It's all around trust. How do you trust what you are going to deploy is going to work in theater every time, right? And so we had a close relationship, again, with that customer. We developed, utilizing a large percentage of the processes that we developed on our machine learning operations platform, but also in concert with the customer, because they had unique requirements. And what we found is that every customer has unique requirements as we go to deploy. And so I think the important part for us is to ensure that we're embedded and that we're developing processes. So as we deploy, we can monitor these models, we can then retrain these models, and then we can redeploy in the field. And that's part of what we did in that example was we collected additional data. We helped reduce false alarm rates for the operators on board that ship and to help thwart attacks. And so, we talk about the need. The need is really generated from the threat. And for us, it's all about closing that OODA loop. How do you close, orient, decide, and act? Like, these decisions are being made at machine speed. And we need to be able to update models and provide them in the field at that speed so we can support that customer. And I think that's a really good example of some of the things that we've done. So it was a combination of internal technologies that Lockheed built, data that we had, customer data, their willingness to work with us on a specific pipeline that would get through authority to operate and actually go deploy into theater. It was all of those things. It takes a partnership across private industry, across large language model providers that we also have close relationships with, hardware providers, because we're actually providing hardware into the ships. It really takes the entire American industrial might, right? Whether it's big tech, whether it's large language model providers, whether it's defense integrators like Lockheed Martin, and our customers, really understanding their needs. It takes a combination of all those things.
Yeah, Greg, you touched on the AI lifecycle, but also a little bit the different layers of the AI stack, the chips, the infrastructure, the compute, the data centers, the energy. What are the biggest considerations about thinking of making sure that the whole stack is ready to deploy AI into the national security context?
Yeah. When we think about that, to me it comes down to trust, right? What is trustworthy AI and how do you deploy trustworthy AI? So I think there's a couple components to that. The first is governance, right? So do you have a governance process around what we're doing? So we work very closely with NIST and the risk management framework to ensure that we are flowing down those requirements into what we are doing. We look very closely at our supply chain. So AI is typically actually a pretty small part of a much larger software ecosystem that gets deployed into national security missions. And so understanding your underlying software stack, things that Lockheed Martin has built, other either open source or closed source technologies that we're bringing in, and doing a supply chain risk assessment on what is coming in is really critical. So that's a big part of the governance piece. I'd say transparency and traceability is a really, really big piece of this as well. And so being able to, it's not just about what we build and using our data to build unique algorithmic solutions that are solving problems for customers. It's about how we do that. And so having automated, repeatable pipelines that are transparent to our government customers are really critical for them to understand how we're building our models. Like open book, right? Like here's how we did it, right? And here's how we deploy. And I'll just say the last piece is around security. So one of the key focuses for Lockheed Martin is what we do around red teaming. So having automated security controls, having human red teams that go off and red team these models, whether they're machine learning models or generative AI, before we go deploy has been really critical for us as well.
I think the trustworthy of particularly state-of-the-art models is going to be particularly important and particularly challenging. I think the capabilities that state-of-the-art models provide are crucially important. I mentioned like they're idiot savants, right? We're going to have to be able to figure out how to leverage the savant piece. Organizations that figure out how to leverage the savant piece are going to be so far ahead of organizations that don't. We have to be able to do that for national security. But they're also idiots. They do really, really stupid things in strange situations. So we have to figure out how to contain the idiot. And organizations that figure out how to leverage the savant and contain the idiot are really going to be worlds ahead of the coming tidal wave. I think that the national security applications and apparatus are going to be slow to adopt because of the potential brand damage. And like the US government, the US national security has a huge brand that we need to protect, but it's going to be critically important that we lean in and figure out how to do that sooner rather than later. And all of that comes down to trust, as Greg was saying. I think the guardrails that we put on the state-of-the-art models are very important, and that technology, that science is imperfect at best. We're moving very fast towards agents and large language models that do stuff on our behalf instead of just talking to us on our behalf, like coding and then taking action in our desktops and in the real world as well. Again, that's super important technology, has lots and lots of implications for national security. We 100% need to lean into that technology. But part of leaning into that technology is figuring out how to make those guardrails, make them safe and trustworthy. And there's no reason to think that the guardrails on chatbots are going to be any better as guardrails on agents. And so that's an area where the research needs to go much, much faster than it has been. It's an area where the national security imperative is more important than the commercial imperative. So this is a place where we really need to muster the national security research aspects and go faster in this space. This is where DARPA has a responsibility to move, and we need to take that seriously.
DARPA, an amazing organization. We're, as an organization, right, we are, to your point, moving very quickly from just chatbots to automated agents, automating workflows within our own organization from an enterprise standpoint. I think the lessons learned there, right? So we're working to democratize these agents across the business. And that's good if, someone's on their personal computer and they're building an agent to do, maybe I'll say a less critical workflow than, deploying an algorithm into theater. But I think as a community, as an AI community between the government and industry, we can come together to really solidify what that governance structure looks like around deployment of agents. Agents are like collapsing the application layer, right, Ben? So to use a simple example, like it's not just, you're not going to be interacting with the applications on your machine. Now you're just going to be talking to an agent. So now apply that into national security, right? And so we have all these bespoke applications, but these agents are going to have access to the underlying data, right? And so how we govern that for us, we're still thinking about it, right?
Well, it's a fraught problem, right? Because like people program computers in computer languages for a reason, right? Computer languages are way more precise than natural languages. Think of all the ways that when you speak in natural languages, you can be misunderstood, right? And that's when everything goes smoothly, when you're talking to smart people, right? Like, how does that manifest in fraught national security related problems, right? It's a super hard problem, even when everything is well intentioned and everyone is trying to be well understood.
Yeah, and there's a gradient. There's this scale between non-critical workflows that maybe some of your automated agents are running, and then really critical workflows. And then there's more of a white glove engineering component to that. And how you govern that, I think, is going to be really, really important as we move into the future.
Weigh in a little bit on the open and closed systems debate, and maybe we'll even broaden it a little bit to kind of, you were talking about kind of, Greg, open deployment where the whole life cycle and infrastructure is traceable and transparent.
Sure.
Talk about those kind of issues.
Yeah, so from an open-closed large language model standpoint, for us, no pun intended, we're keeping the aperture open, right? And so we work very closely with some of the best open source large language model providers. Many of them are here today. And there's definitely positives to that. Now you have a community around open source that can look for vulnerabilities in that. So there's a lot of positives to that as well. And like Dr. Fisher said, we are also working very closely with some of the best closed source large language model providers. I think, from a Lockheed perspective, it really comes down to model performance, benchmarks, the cost of running these models. So for us in our AI factory, what we're doing is running a lot of the open source models on-prem. So we have hardware on-prem, and from a cost standpoint and a scaling standpoint, that helps us scale at lower cost. It also helps us meet teams kind of where they need it, right? So to have a modular system where we can provide specific parts of the platform stack to them has been critical. But I think for everyone, I think, Dr. Fisher, not to put words in your mouth either, but I think we're pretty open to working with everyone and understanding where that's going to go. And I think you're going to use different models that are either ragged or fine-tuned based on your use case and based on that model's strength. They're all going to have different strengths. And when you bring your own data to that model, that's where you've really seen an explosion of innovation, at least at Lockheed, right? So if you can pair up a subject matter expertise, someone that really knows radar, for example, with somebody that really knows how these large language models work, and building it on our platforms, that's where we've really seen an explosion of innovation at the capability level for us at Lockheed.
Yeah. I think we saw, like, when Meta released their models open source, there was an explosion in the ecosystem of intellectual capacity and researchers in academia being able to go do a ton of research that they couldn't do before because they didn't have access to the models. So that was transformative from a research perspective. It unlocked a ton of research that wasn't possible before. They got a lot of buy-in, and they got a lot of people working on their platform and working in their ecosystem as a result. The same thing happened when DeepSeek released their model, right? And their model, those models are now the state of the art. And so, like, researchers, they want to work at the state of the art. And so they're currently getting traction. It would be great if we had US state of the art model right now that's open source. I think Meta is working really, really fast to try to rectify that situation. They're struggling a little bit at the moment. I think there was a debate about, well, closed source allows us to control the models, and if we have it, maybe we want to be able to control the models. Maybe they're too dangerous to have open source. I think that the rate of evolution and understanding of the models and the fact that now the cutting edge seems to be on inference time instead of training time, and that can be done with those benefits are being leveraged on the models that are already out there. I think that debate is largely past right now, and so obviously the foundation model companies are like, they're the ones that are already at the state of the art, and they don't want to, like, turn their crown jewels over to the open source community. Yeah. So I think it's important to realize that the incentives for the followers are to release their code open source, because then they get the benefits of the entire ecosystem.
Yeah.
I think in terms of adoption, right, we don't know enough right now to be able to microscope an entire open source model to understand, are there vulnerabilities in there? So, like, the trust, it's really dangerous to just adopt wholesale a model and assume it's all okay if you don't trust the ecosystem. So the technology is evolving so fast and the benefits are so high, you need to adopt, but, like, where do you get that trust from is complicated. So
I'll just, one quick add to that is, at least for us, we've invested in the Lockheed AI Center and these platform capabilities for a while now. And when Llama, so we started as an MLOps platform, but rapidly transitioned into a generative AI platform sitting on top of machine learning operations. And when Llama released their first model, we were able to consume that in like 3 days.
Yeah, exactly.
Right. Organizations, teams, the government, we all have to be investing ahead of that. Because then there's the next thing. Now there's quantized models that are going to be running on the edge and smaller compute, right? And so I think it's really important to continue to invest ahead of need, leverage the best that are coming out of these big tech companies that are doing amazing things, and being the best at applying that into the DoD space.
Since I am PunchBowl News, I'm contractually obligated, Greg. How does Congress play a role in getting this right? The funding levels, the directives, what would be your suggestion to the Article 1 branch?
Yeah, I think really understanding the guardrails around AI and how we can deploy, how rapidly we can deploy is really important. I'll say, working with amazing institutions like DARPA and having those public-private relationships and ensuring that those are as tight as possible and that we really advocate for legislation that's pushing in that direction. Because what we really need at the end of the day for AI to win in this space is all of American industrial might, right? It's all, we need all pieces of the puzzle. We need foundational research that comes out of DARPA. We need defense primes. We need defense tech. We need the big defense companies. All of us have to come together in support of national security. And to me, bringing everyone in the game, creating that competition is going to benefit us as a nation.
Dr. Fisher, you came from academia. You spent many, many years there. How can academia be the third leg of the stool here with the private sector and government? What can they do kind of uniquely, and really the whole educational system to kind of push this forward?
Yeah, I think what academia does really well is ask basic science questions, and I think that industry is working really fast towards that, providing really fantastic capabilities that have obviously commercial viability, but academia can step back and ask those core questions about how, what is actually going on and how do we keep guardrails on, and a lot of the recent advancements in, for example, inference time actually drew on academic papers. So I think that academia is continuing to contribute that basic understanding, and that's a really, there's tons and tons of really, really important questions about even what we're doing now and what's just over the horizon that academia is likely to provide the really critical answers to that question. And that's part of that is why we're hoping to stand up this AI Forge initiative jointly with the National Science Foundation, with academia, with DARPA, and with the foundation model companies to leverage their capacity and their insights and their brain power, graduate students too, to train up the next generation of thought leaders in this area so that we keep that pipeline that has been working for, since World War II, more or less, to power the engine of excellence in the United States. We want to keep that going.
Couldn't agree more.
Yeah. There's so much we could talk about, but I always like to end with a little lightning round, one sentence. If we were to meet again in a year, maybe we'll be invited back. I don't know. I think we're doing a good job. What would we be talking about on this topic in a year, do you think?
Agents.
Automated
agentic workflows, how we govern that, how automated we let them be within our own organizations and out deployed in the field. Like I said, just very rapidly, I think you're going to see this application layer collapse. And on top of that, we're going to be interacting in natural language with these agents. So agents is what we're going to be talking about as we move into the future.
All right, take us home.
Oh, that was going to be my answer too.
Oh, sorry.
I think maybe another consequence of that is I think we're going to see job displacement and the consequences of that, which is going to ramify through national security as well. But a consequence of that, I think, is also entry-level jobs are going to change fundamentally. If a lot of entry-level jobs, they're not all going to get eliminated, obviously, but they're going to be fewer of them, and more of them are going to be about supervising agents. So if your entry-level job is supervision, how do you train people to do supervision when they've never been supervised?
Had the job.
Right? If their entry-level job is supervising AI, but maybe all is good because in college, maybe what they're doing already is supervising AI agents writing their homework already. Maybe we're all solved because maybe they're already doing this in college and high school, and we're
I still write my own notes. All right, I think we'll leave it there. Thank you so much for everyone in the audience, and thank you so much, Dr. Fisher, Greg Forrest, and please join me in thanking the panel.
Thank you.